up again, swing over here, back out. Okay, so I'm going to need you guys to help me out here. This is for median earnings for women in 05. Please give me the model again. Y equals, was it 80-ish?
The top one or
The A, sorry, yeah, the A value is the slope on the TI there. Oh, speaking of which, thank you, Tori, for bringing that question up. When you guys run the lin-reg command, you see how at the top it says Y equals AX plus B? It's very rarely that I say this, but this is one of the best things TI ever did. They don't use the letter M for slope. I love that. M has no, as far as I can tell, no historical significance. The letter M. In mathematics, we often try to use letters that kind of mean something to stand for something. Like, for example, mu. The Greek letter mu I quoted earlier for the average. The average is more traditionally called the mean. So they called it mu because it's the first Greek letter in the word mean. Sigma is a measure of standard deviation or spread. Pi in a circle is a relationship about the perimeter of a circle. We call it the circumference more recently, but it used to be called the perimeter. So usually in mathematics, all those numbers have letters that mean something. For some reason, the slope got stuck with M. I have no freaking, I guess S was taken, I guess. But I love this because it's alphabetical. A, B. Done. That's it. I mean, if you can't be logical one way, be logical some other way. So this is your slope. And this is your y-intercept. And I think that's one of the more logical things TI ever did, personally speaking. So when they, Tori, go.
I have a question.
Yes.
When you go to the linear model right here.
Yes, ma'am.
The
The lin-reg.
right, and it says store in.
Y1.
Yeah.
Yes, ma'am.
How do you put the Y1 in?
Press the bars button. Go to function. And do you see Y1 now?
Yeah.
Yep, there you go. Press enter, and it should be there.
Right,
Yes, ma'am. You got it. Your screen's a little different than ours, isn't it?
Yeah.
It's a little tad bit different. Yeah. Now it says like reg EQ, reg equation. And yours, yeah, all good. So this is how the TI gives you the results. You have to take all of that and turn it into Y equals 80x minus, we'll call that 488. Let's just round it off to the nearest dollar and make life easy for us. Now, the model, in my opinion, is not complete yet. Because if you just hand that to someone here, Merry Christmas, that doesn't tell them what you're talking about. So I always demand from you, and sometimes I give it to you too, I demand an explanation of what X and Y are. I want to know, when I'm looking at this linear equation, I want to know what X and Y are. Otherwise, it's just an interceptic math problem from Math 60. So, what is X?
80.
Years of school.
Oh.
Yes! Good! And I love that O that I heard from over there, because by the time we get done crunching all these numbers, we may have forgotten where we started. This all started with a very interesting graph about earnings, didn't it? But by the time you get done crunching numbers, you get to the end, you're like, I gotta get a beer. Now what the hell am I doing this for anyway? This reminds you what you're looking at. X is years of schooling. What is Y? Good! It's your median weekly salary. Good! In dollars. In dollars, yes. Cool? Now, that's the full model. In my opinion, that is a mathematical model. Because it has an equation, and it has a description of the variables involved. And that's what makes me happy. That's what makes me happy.
So we just rounded it to the nearest.
Yeah, because honestly, they gave us digits that were to the nearest whole number. I don't have any reason to believe I could have sense like that. That doesn't make any sense. The precision's not allowed, in my opinion. I'll tell you what the round. Don't worry about that. Look yourself up with that for. Okay? Don't ever worry. I know in the first couple quizzes I gave you guys, I was knocking you for rounding. That's because I want to make sure you know how to round. I don't expect you to know to which place to round and a precision analysis. I'll do that for you. Just make sure you round correctly, I guess. Like, don't call that 100 if I'm telling you to round the nearest whole.
So instead of storing it, I should have just.
store it?
I stored those answers.
Oh no, that's fine. You can totally do that if you want to. And as a matter of fact, they're already stored in the variables little a and little b.
Right.
You don't have to though.
Okay.
I'm going to ask you most usually to write down the model for me, and then give me the x and the y, what they are. Now that you have this, there's all kinds of stuff you can do with it. But before we get into that, I want to make sure you know what you're looking at with those two values. Crystal asked a very good question when she ran this. She said, this is negative.
Yeah, but I remember now that you said the y-intercept.
Why is that negative? First of all, negative 488 what?
Dollars.
Dollars. Negative $488. Okay, so what does that mean? We're going to lose money if we go to school?
It's when
You
x
go for
equals
0
0.
years.
Yep.
When x equals 0. Remember, the mathematical model doesn't know we're talking about money. It just knows we put data in, correct?
Right.
So, the interpretation of that y-intercept is if x equals 0, I'm going to put it in parentheses, years of school, then y equals negative 488, quote-unquote, dollars. Now, the literal interpretation of this is that if you don't go to school at all, you're going to lose about 500 bucks a week. That might be true, maybe. But the important thing to realize is, yeah, that's a y-intercept, but all that does is it takes your line and fixes it in the correct up and down position. That, in and of itself, doesn't do a great deal. All it is it's a part of the mathematical model that fixes it. Once the slope is fixed tilt-wise, that shifts it up and down-wise and locks it in the correct place. So that really doesn't tell us a whole lot of anything. Unless we shifted our data so our smallest data point was 0. Which we did not do. We started at 10.5. I think it was a perfectly logical thing to do. Good, 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 good. So, everybody okay with that? Is that fair?
Yes.
Here's what I want to talk about next. That. And I harp on this all the time with linear model. I don't know what that means. I want to know what that means. 80. It's beautiful. I want to hear. Let me see hands on this one. This is important. Because it doesn't take more than 2 thumbs and good reading skills to put the numbers into the TI. But it takes a lot to understand the number that comes out. And that one in particular is the one I care the most about. So who wants to tell me what that 80 means? And you're going to have to use both dollars and years on this one. It is the slope, correct. That is the slope. Just like this is the y-intercept. This is the slope. But I want a conversational explanation of what that slope means. Crystal, give it a whirl.
Isn't it on average
I love that.
per year that you go to school, you're getting an extra $80 a week?
That's exactly correct. 80, you don't see this, but it's 80 over 1. The TI doesn't show you that. As well it shouldn't, because it's simplified down. You divide by 1, it's the same thing as not dividing by anything. 80 over 1 is equal to 80. Now, you see how there's 2 values. There's an 80 and then a 1. The number on top is a dollar amount. The number on the bottom is an X amount. So it's a Y over an X. How do I know this? Do I expect you to know this right now?
Rise over run.
Yes, because it's rise over run, because it's change in Y over change in X from back in your algebra days. So yeah, you need to remember that. And you will now if you don't. 5 minutes, you'll remember it again when we do our measure our arms. You say that again?
Rise over Rome.
Rise over rum. It's even better. That's like Friday afternoon though. So then you have to apply the correct units to it to make sure you understand. It means $80 per one year.
$8 a week.
$80 per week. That's true. That's true. Per week. Every 1 year. So what this means is, for every extra year of school we go to, the median earnings per week go up $80. That's what that implies. For every additional year of schooling that we go to, your median weekly earnings go up by $80. This, Andrew, go.
I was just add a question. Does that mean that you can interpret that to say that until you go to school for 6 years, you really can't earn any money?
Good, good. Can we answer that question in like 2 minutes? Because I want to go both ways with this, if it's okay with you. I want to go both ways. I want to bring back the TIs because there's a really cool tool on there you might have either never played with before or maybe you haven't played with in a while and you might have forgotten how to use it. Andrew asked a very good question. Does this mean that until you haven't gone to school 6 years, you're still making negative dollars and you have to go to school at least till 6th grade to make money? We'll come back to that. We'll come back to that. It's okay. I don't want to push that off. I want to make sure we understand this.
So for every year you go to school, your earnings go up.
$80 per week on average. And what Crystal said and what Linda just reiterated is the perfect way of describing it. I love the word on average. On average. And why do you have to say on average? Let's swing back over to here.
It's the best fit line.
It's the best fit line, which is an average best fit line. When we take a look at this graph, friends, it's not perfect. It's not perfect. What that line does is it smooths out all the little goofy transitions. It smooths them out into a straight line. Now, I don't think anybody doubted that that data looks straight. It looks. Now, some of you might say, wait a minute, it looks like it curves a little bit too. It looks like maybe it goes up and then it comes back like this. Yeah, you could totally do that if you wanted to. You could totally run how many times does that turn? 1, 2, 3. Go ahead and run a quartic model on that. You could. Watch this. Watch this. Watch this. Hang on. So that's calc. I can run a quart reg. We'll come back to this. Might take a little longer. Oh, no, there it is. Okay, you ready? Here we go.
Oh, wow.
Oh, I forgot to hit Y1. I'm sorry. I did the same thing I was yelling at you guys not to do. Here we go. Okay, you ready? There it goes. See what it's doing?
Yeah.
It's kind of swaying, it's shucking and jiving and catching the points as they go, right? It's doing a little bit of this. Does that fit better than the line? Okay, maybe. But if you had to talk to somebody about how much more money they're earning per week, which one of those numbers do you want to use? None of them, because none of them actually talk about that. Those are the coefficients on the model. That times x to the 4th plus that times x cubed plus that times x squared.
Wow.
So yeah, I mean, you can look at all the little turns in the data and try to match it perfectly. Nobody actually does that. They say, they look at the data, right? They look at the data, and they say, that looks like it's pretty much a straight line. And they run a linear regression. Is that fair? Yeah, yeah. So, and I'll tell you in this class, run a linear regression, run a quadratic regression, run an exponential. I'll tell you which one to run. And then sometimes on the out-of-class parts, I'll ask you which ones you think you should run and why. You will never run one of those monstrosities because there's not much of a point to it. Four dimensions is one more dimension than we're used to dealing with. I mean, if you include time plus x, y, and z. But I mean, anyway. So anyway, let me run this back through y1. Okay, now Andrew asked a very interesting question over there. He said, does this model mean we have to go to school till we're in 6th grade before we start making money? Andrew, how did you get that?
Well, I was just 6 times 80.
So he did, in his mind, 6 times 80 is 480 bucks. And that almost cancels the negative 488, which would zero it out. You can do that in here. In case you have never seen this before, press the second graph button.
The second graph?
Second graph. Does anybody's screen blank like mine is? You guys have numbers in your screen.
I know.
You do have numbers in your screen. Do this for me, friends. Everybody that has numbers in their screen, make sure your cursor's over in the X screen. Press the delete button a few times.
Yeah, I'm afraid.
Are the numbers going anywhere or are they staying
They're
there?
gone. They're gone.
They're gone, they're staying, okay.
Mine are staying.
If they're gone, hang tight. If they're staying, here's how you can get rid of them. You probably should only have to do this one time and it should stay that way. Press the second button. Press the window button. Okay, it should look something like this now. Okay? I don't care what this says, because it doesn't matter. This is the important thing down here. Where it says int print, change that to ask. Because it's going to be asking you for the independent variables. Independent variable is usually what? Mathematics. Usually x, Joe, usually x2 or yes. How about the dependent? Dependent variable? Leave that on auto. Leave that on auto. Now, you'll be able to enter values in for x, and it'll tell you the values for y. That's okay, because if I go back, second graph, get back to your table, it should be blank now, yeah? Should be blank. Jordan?
I accidentally deleted my Y1.
Oh, just run the linear regression again. Yeah, if anybody doesn't see Y1 right now, that means when you ran the linear regression, Jordan, make sure you put the Y1 after it.
Okay.
Otherwise, it won't store it to the Y1. What that table is doing, the second graph menu, that Y1 is looking back at the equation you have in Y1. And it's pulling Y values from that equation. Does that make sense? So if you don't see a Y1, it just means you didn't put the Y1 in. So it's vars, right, enter, my friend. That'll go get it for you. Cool? Now watch this. Get to your table, second graph, and now you can start throwing X values in, and it'll tell you the Y values. So for example, for 0 years of schooling, we're down to negative $488, but we knew that because that's the Y-intercept. Now you can start putting years of schooling in. Hey, if I go to school for 1 year and pass first grade, I'm going to lose $80 less per week if I'm a female in 2005. 2, 3, 4. How much stock should we put in these numbers, guys? How much stock should we put in those numbers? Very little. Very little. Because those numbers, those values you're getting out there, those negative values, are what we call extrapolations. They're called extrapolations. I'm going to erase the raw data up here and give you 2 terms I want you to think about. 2 terms I want you to think about. We're doing good on something. Yeah. I'm trying to measure our forearms here in a second. When you have data, there's 2 things that you can do with that data. You can get a model. Once you have the model, you can use your model to either interpolate or extrapolate. Interpolation is usually pretty safe. Extrapolation can be very dangerous. Extrapolation is essentially what caused the financial collapse in 2007. We'll talk more about that in a second. Extrapolation is when you use your model to get outside of your data range. When you get outside your data range, you're extrapolating. When you get outside your data range. So in other words, our data range starts with X values of 10.5 and ends with X values of 21. If you go less than 10.5 or above 21, you're extrapolating. And the further away you get from that, the more dangerous it gets, because it's possible that the behavior will not continue outside that range. All you've got is a snapshot between 10.5 years and 21 years. You have no idea what's happening before 10.5, and you have no idea what's happening after 21. All you know is what's happening between 10.5 and 21. This is how the housing market got into the problems that it did. 2000 to 2001, my God, house prices doubled. 2001 to 2002, my God, house prices doubled again. 2002 to 2003, my God, again. They doubled again, they doubled again. And what did we keep assuming they were going to do? Double. And what did they do? Shh. The pattern broke. And that's the problem. They dropped, the pattern broke. Even if they flattened off, the money that was being leveraged against growth would have seemed negative even if they flattened off. But they didn't, they actually dropped. Please, David.
So extrapolate's a fancy word for guess?
It's an inference, not a guess so much. Because you're using a model to get the value. Everything what David said, he said extrapolate's a fancy word for guess. It's better than a guess because you're actually basing it off of a model. So you're not guessing, but you're asking your data to potentially do too much. You're asking your data to, okay, data, pretend you're going to do this forever. And you always used to do it. What would you say, crystal ball, if that was true? That's a big if. That's right, that's a huge if. So it's not a guess, it's an inference. But it might not be a valid one. Is that fair? Yeah. So I think halfway between a guess and certainty is where extrapolation lies. The trick is you don't know how close it is to either one. Does that make sense? I mean, it's mathematically based, of course. Now the other side of the coin, well hell, if we make $80 additional per week for every extra year of schooling, never leave school. Huh? Let's go to school for 100 years. Let's go to school our entire lives. Let's go to school for 50 years, right? For 50 years. 50 years. Type in 50, boom. That means we're going to make $3,500 a week. Or you're not. Because that is now a wicked extrapolation, isn't it? You're well past the 21 years of schooling that we put in. There is no guarantee that that scatter plot will continue to go up. As a matter of fact, what do you think it might do past 21 years? What do you think? I'm going to guess it's going to flatten off. It might have hiccups in it, but I would guess if you track people that go to school for more than 21 years, you're not going to see a continual rise. If anything, it'll flatten and maybe even drop. Maybe even drop. But it's going to be harder and harder to find those folks, too, that have gone to school for 30 and 40 years.
Those are the people who live off the.
Live off their... Oh, student loans?
Yeah, student
Yes,
loans.
the government is trying to fight that, but whatever, let them.
Yeah,
Let
just
them.
keep going.
When they're
and
working
they're
at it.
not.
Yeah, but that's the idea, is that you got to be careful when you get too far extrapolated. It's safer to interpolate, which means you stay within your data range. Can anybody see why that might not be as desirable as extrapolation? Because we want to predict what's going to happen, Nick. Yes! Interpolation's great, except it's kind of like saying, well, my house was worth this much 2 years ago. Fantastic, and maybe you need to know that. Maybe you need to know that. But the thing is, you probably want to know, when can I sell my house? When can I sell it? Well, when it's worth a certain amount. When's it going to be worth that certain amount? And that's when you kind of have to extrapolate a little bit. Now, there's a way to safely do that, and I want to get into that next. And I say safe. Safe might not necessarily be precise. This is kind of sounding cryptic, I know, I apologize. But I have another set of data that I want to play with. We're going to generate it with ourselves here momentarily. Does this make sense, at least so far? Let's go through this bit by bit. Number one, we got the data in the TIs. Number two, got the model. Fair enough? We'll do it again momentarily. Number three, we wrote the model down. Yes, we're happy with that model. We're happy with what it tells us. Number four, we interpreted the slope. I really care about the slope. The y-intercept I don't care about so much. I really care about the slope. We know what the slope means. Thank you, Crystal and Linda, for that explanation. It was perfect. And number five, or whatever I'm up to now, F, G, H. This table function, yeah, good, happy, yes, it's a very, very good thing. It's a very, very good thing, yes. It's quite good, it's quite good. Okay, let's get a new data set. This will get you guys up and moving a little bit too.